Welcome to the talk, Keeping Your Gradle Builds in Top Shape. By the way, there's like 3 seats up here in the front, so if you guys don't want to stand, feel free to come up. Yeah. I think there's actually 4 or 5 seats, yeah. Cool, so before we get started, I'm just going to do a little intro. So I'm Nelson. I'm lead solutions engineer here on the Gradle Enterprise team. Before I worked at Gradle, I was an Android engineer, just like many of you are. Worked on large projects and teams, such as the SoundCloud app, Square. I've also worked at random small startups. I also maintain some Gradle plugins that you might know, such as Fladle, which allows you to easily scale your instrumentation tests on Firebase Test Lab. And I also maintain the Gradle Doctor, which gives you actionable insights for your Gradle build. And here with me today is Inaki.
Hey, I'm Inaki Villar. I'm a new joiner in Gradle. I'm working as solution engineer. I consider myself a pure Android engineer because, in that we have seen several of you so many years, right? So I think that I'm an Android engineer. I've been working previously in Tinder. When we have some guys here, Tinder, Agoda, it was like in Thailand, very cool company, Ryanair, and IdeaNo. So actually I'm very focused in the build performance, everything related with the Android builds, of course, but purely in Gradle too. And yeah, so GD in Android and Kotlin.
All right, so what is a solutions engineer? We see a lot of builds. We see Android builds, we see Gradle builds, we see Maven builds, from small teams to 1,000+ teams with hundreds of modules, thousands of modules sometimes. And what we do is we help our customers optimize and understand their builds. We help them increase their build stability and preach developer productivity. Another part of the work we do is we help improve the Gradle ecosystem by fixing issues in open source plugins that affect our customers. And then we also meet with Google and JetBrains to help prioritize specific issues that are facing our customers. Okay, so why is developer productivity important? If you're at a Gradle talk, this is what you're always going to hear. So what I like to say is when you're developing Android, you can work on 2 things. Of course, there's many other things. You can work on feature development, and you can work on tech debt. Of course, yeah, there's other things. But what I like to say is that refactoring, or tech debt includes refactoring and improving builds, and slow builds are tech debt. And it always pays off to work on slow builds because it's very easy to calculate the amount of waste that slow builds generate. It's time. It's your developer time. So here's a simple calculation. If you have 60 seconds of waste per build and you build 50 times a day and you have a team of 50 developers, that means you lose 42 hours per day, which is a lot of time because 40 hours is a work week. And it doesn't include lost focus and things like that. There's also a calculator here where you can type in the number of builds you have and translate that along with salary into dollars if you like, gradle.com/ROI calculator. But yeah, the point is that fast builds matter because 42 hours per day is a work week, and that means you could hire 5 new people without paying them recruiting costs, overhead, things like that. So that's why it's really easy to justify working on improving builds. All right, so we're not on the Gradle team, we're on the Gradle Enterprise team. So we always like to ask the question, how many of you have seen or used a build scan? Hands up. All right, we got lots of hands up, that's really good. Then the second question is, how many are Gradle Enterprise customers? A good number of hands, cool. So if you haven't seen Gradle Enterprise, I always like to do a quick little demo. So we have a lot of open source partners that are open source projects which are our partners. You can see all of them on this website. They include the Spring team, Micronaut, as well as the Android X team. And so I'm just going to do a really quick demo using the Android X instance just so we're all on the same page and we know what we're talking about. So So yeah, here, this website, anyone can go to it, ge.androidx.dev, and then you'll see a list of scans. If that means every single developer contributing to Android X is publishing a build scan, as well as all the CI builds. You can type in the top here, CI, to see all the CI builds. If you want to say, okay, what's the number one reason why my CI builds are failing in the last 7 days? Here's your answer. If you want to see the number one reason for local failures, here's your dashboard. You can see if your local builds are getting faster or slower over time. There's a performance dashboard where you can get individual build performance and see how much each build is benefiting from the remote build cache. And there's also a test dashboard here where you can see, for example, the number one reason for a failed test. So that's a really quick breeze. If you're interested in more, come to our booth or just browse this on your own. Okay, and the next most important thing of every Gradle talk is what is build caching. So let's say you have a Java compile task in your Gradle build. There are inputs to this task, such as source files, compiler arguments, and dependencies. And tasks, so these are the inputs to a task, and then you also have outputs to a task. And any task can be made cacheable. When it's made cacheable, that means that the inputs form what is called a cache key, and that's used to uniquely identify the outputs to the build. So when you fetch it from the cache, you look it up, it's like a hash map, you ask it for the key, it gives you the outputs. Yeah, so you ask the build cache for the cache key, and it gives you those class files. That's the output for a Java compile task. Now this is really simplified, there's a lot more inputs, there's a lot more outputs, but this is just the very simplified version of a Java compile task. Okay, so I'm here to show you a thing we call the build validation script. So we often help customers make sure that their builds are 100% cacheable, that they're getting cache hits for every single task in their entire build, that every task is completely up to date. And we have some scripts that make it super easy to do this. So there's a series of 5 of them for Gradle builds. The first one verifies the up-to-date checks, aka incremental build. The second one verifies local build cacheability. The third one verifies the cache relocatability of your build. The fourth script helps you verify CI to CI. And then the fifth script helps you verify from CI to local builds. That is, that if you build on CI, your local build can pull all the artifacts from the remote build cache. Now I'll get into how each one of those works on the next slide, so don't worry if it's a little confusing. So yeah, the scripts are named exactly like that, and you run them on your local machine. They're just bash scripts. They're very easy to use. They have an interactive mode where you can just run it, and then it'll ask you, what Git repository you want to use and those types of things. And there's also the command line invocation where you can run it automatically, so it'll automatically execute your build and check for cacheability. So what does the first script do? First thing it does for you is it disables build caching completely, because this is only to check the incremental build or up-to-date checks. Then it runs your build with a task, including clean, so that is, it cleans all the outputs first, and so you have a clean slate. Then it runs the exact same build without clean. And then what you have to do is determine which tasks were executed and why, using a build scan. You assess which of the executed tasks are worth improving, and you fix them. So yeah, 1, 2, 3 are automated by the script. Improving your build, that is not something that can be automated with the script. So that's something that you have to do and examine. And I'm going to show you how to do that with the output from the build validation scripts. And yeah, if you were to run this manually, it's very simple. It's just that it's Gradle clean assemble -- no build cache, Gradle assemble -- no build cache. So when you run that using the build validation scripts, you get a big, nice output that looks just like this. And I'm going to break that down. I know there's a lot of outputs. So yeah, looking at the top part, the summary, there's of course the project that you ran it on, There's the Git repository. That's an input that you gave it to the scripts. It checks your repository out from a clean slate every single time in a clean directory, so there's no other interference. The point is that each of these experiment scripts can be executed and repeated so that when you want to rerun the experiments exactly like last time, you get the exact same result. You give it a branch name, you give it a Git commit ID. Sometimes projects have like multiple Gradle projects in the same build, so you can give it a sub-project. You give it a task like assemble. Assemble debug is the common case for Android builds. I'm just going to skip over a couple things. You give it an experiment ID. So this helps you filter in the dashboards for that build. So what that does is it adds a build scan tag. You can also add build scan tags in your build via the Gradle files or also via the command line property. And then in the dashboard, similar to how I did earlier and I filtered out for CI builds, I can filter out for builds that executed that experiment. There's also the experiment run ID, which corresponds to a specific execution of that experiment, so that way you can just find those two builds that corresponded to that experiment. And then you also get an experiment artifact directory. So it copies the outputs of both executions, both builds, to these data directories, and it looks like this. Inside of it, there's the first build and the second build directory. And what this is really useful is if you have differences to the inputs of any of the tasks, you can easily examine any of the files that were part of the build. So yeah, typically, before we had these scripts, if you had a difference in an input from one build to the other, you'd have to rerun the experiment, stop after the first build, and then grab that output, then run it again, and then grab the output again. But in this case, you can examine any file because it's copied to a new directory at the end of each execution in the experiment. All right, and then the last thing is build scan. So you get a build scan for the first build and the second build, and hopefully a lot of you are very familiar with build scans already, so I'm not going to go too much into that. What you also get is investigation quick links. So these are like little shortcuts to specific parts of the build scan. So for example, the task execution overview takes you to that page in the build scan, so you can see which tasks were avoided via the up-to-date checks. The next part is executed tasks timeline. So this is the timeline of your build scan, and here you will see, hopefully, 0 executed tasks. Now, if you ran this experiment and you don't see 0 executed tasks, it looks something like this. And then what you can do is you click this little button in the build scan, and then it'll tell you exactly why that task executed, which input changed. And then the last part is the task inputs comparison, so you can compare the first build and the second build and see, for example, if you ran a successful execution of the experiment, you'll see that both builds have the exact same inputs for each task. If they weren't successful, then you might see a difference to things like build timestamp or version numbers, and then you can go and figure out how to either remove these from your build or make them consistent in some way. Maybe you want to have debug builds where they're consistent and release builds where they're not. There's many different options, but once you see it in your build, you can see the impact of it on the timeline, how much time that's adding to your build, and then determine if it's worth fixing. You can also do a task input comparison manually. So if you have 2 build scans, here's a little video of how to compare 2 of them and get to that same screen. So yeah, you don't need the scripts to get to all these things like the task input comparison or the timeline. It's just like little shortcuts that the build validation scripts do. All right, and then the very last part of the output is this script that tells you exactly how to rerun that experiment. So now you can adjust your build scripts and then rerun it, and then it makes it very easy to improve your build. Then you can check the output. You can just let the script run and go get a coffee or something. Cool, so that's the first experiment. And yeah, you can run it either interactively or via the command line. The second experiment is pretty similar, except in this case, both builds are executed with the clean task. So that is, and the build cache is enabled. So when you execute clean, then Gradle pulls everything from the build cache. And the same thing, you determine which tasks were executed and try and improve them. Yeah, if you were to run this manually, it looks like this. This is almost the same thing as experiment 1, but in this case, you run it with the build cache. You'll notice that the output is exactly the same, except in the investigation quick links, there's a couple more links. And that is executed cacheable tasks and executed non-cacheable tasks. So when you run this experiment, you want to see which tasks were executed that were actually cacheable. So that is, you had a cache miss, the inputs were different. As well as you also want to take a look at which executed tasks that were not cacheable. Maybe you want to make those tasks cacheable if they take a long amount of time. And you can see that in the build caching statistics page. You can see how much time those added to your build. The third script is also very similar to the second script, except it executes the second build from a different location on the file system. This helps check the relocatability of your build and the cache entries. Oftentimes we see things like fully qualified paths as inputs to tasks, or fully qualified paths being written to files. The fourth script helps check your remote build caching on CI. And it's, very similar, except this time you actually have to execute a CI build, so that also can't be automated. The fifth script is also very similar. You can't run CI build via a script, so you have to execute that manually, but the local build you can execute via the script, and then you compare the inputs. So these are really useful because, especially this last experiment, because this often uncovers differences in environments which might cause cache misses, such as CI build is using Linux, local build is using Mac, or different locales, things like that. So now that we have these scripts, we can automate the execution of these automated build scripts. And we have a GitHub action that we have as an example on GitHub of how to do this automatically. Here's a link to it. I'll also have it at the end of the talk. And so, it's pretty straightforward. There's a couple steps. So one downloads the scripts, and then there's one step to run the first experiment, another step to run the second experiment, and another step to run the third experiment. And you can actually just copy this, and then you can run these on any project on GitHub very easily. The parameters are basically git repo, git branch, and what tasks you want to run. So what you can do is, run these once a week, and then it makes it very easy to check the results, make sure all your tasks are cacheable. We actually do this against all our open source projects. So here, for example, we run it against the Android X build once a week. And here's one of the outputs of the investigation, or the summary for the Android X project. And if you go to that repository, you'll see it's called Gradle Enterprise OSS projects. All right, so that's the automated build scripts. The next part of our talk is going to talk about the Gradle Enterprise API. Before I dive into that, we're going to talk a little bit about the old export API, which is a little bit clunky to use. Has anyone used the Gradle Enterprise export API here? We have a couple people. All right. And if you have used it, you probably thought it was not so fun because it's SSE based. It's like a real-time streaming API that gives you JSON events, except there's no real event model. You don't really know what to do with all this giant JSON data. You have to really dig into it to figure out what to do. There's, for example, we have an example. There's one API that gives you builds, so just build IDs and times, and then you have to use another API to actually fetch the details, and then that gives you a lot of data. But you have no model to really parse it and turn it into objects. So now there's a new Gradle Enterprise API. It's a REST-style API based on JSON, and it follows the OpenAPI spec, which allows you to automatically generate both the models as well as the client. So if you like retrofit, it'll automatically generate a retrofit client for you. If you like Apache, it'll generate an Apache client for you, whatever you like. If you like Kotlin, Java, whatever. Even JavaScript and other things. And there's a build API, so that gives you build events. And there's also the build cache node API that allows you to automatically configure Gradle Enterprise build cache nodes. This will eventually replace the export API, but it doesn't have all the information that the previous export API had. For example, raw build events. Here's a little page with our docs, which is just OpenAPI generated. And yeah, so here are some fun use cases that we've used. Used this API to examine. One is my task worth caching. Another one, rank teammates by slowest average build time. Tasks with highest negative avoidance savings. Users with the most build cache errors. And so I'm going to hand it off to Inaki to talk about, is my task worth caching?
Thank you. Well, actually, that was the first use case that Nelson explained. And so why we need to ask ourselves if a task is worth caching? Because we don't want to fall in the negative avoidance savings. What is negative avoidance savings? That means that we are going to spend more time retrieving the output of the task from the remote cache than executing locally. And it's a problem, right? So let me introduce this use case that actually we saw at Gradle recently. Instead of is a task worth caching, we want to ask ourselves, is a DEX merging task worth caching? To give an idea, so the left column, so you have the execution is 12 seconds, but when the task comes from the cache, it's 20 seconds. So absolutely doesn't have any sense, right, to use the remote cache. But at the same time, you're going to execute this task. DEX merging task is one task that's coming from the Gradle plugin. So some of you, because I know you remember those times of the multi-dexing, DEX limits, and these DEX problems that not anymore is a problem for the Android community because we have the new Android runtime, we have the V8, R8 compiler, but at that time, there was a real problem, right? And still this task is working, so it's there, and the thing that this task is doing is going to transform as an input a DEX files, and it's going to generate an output with a small number of DEXing files. In the code of the DEX merging task, you have the complete description of that. So, but what's the problem of the customer in our case, right? We have one email from one customer. We are spending like 2 minutes retrieving this task from the cache. But we need to perform an investigation. And this investigation, we need to define some assumptions and considerations. First of all, is the task execution time. How long is this task when it's executed? Is 3 minutes? Is 4 minutes? Well, that means that's something, right? So one task that is going to take 2 minutes, it's worth to cache. Let's see next. The size of the task is important too. This task or this type falls in this category. Why? Because as you know, we are dealing with DEX files. And on the main entry point of an Android project, we are going to generate bigger outputs for this specific task. And if we have one problem of connectivity, the remote cache is going to be slower. Finally, we need to ask ourselves which kind of task is this DEX merging task. Apparently, you can think that DEX merging, it's only merging DEX files, so it's going to be driven by input-output operations. But we reviewed the code of the Gradle plugin, and we saw that the action of writing the DEX files is deferred to the V8 compiler. And until there, my knowledge, right? I don't know what's internally doing the V8 compiler, but maybe they are doing some CPU or expensive operations trying to align the DEX files. That's why it's not clear that it was only this bound. For instance, a clean task, a jar task is totally disk bound, and we can, choose if we want to cache it or not. So our investigation was not enough. With this data, we were not able to tell, maybe this task is worth caching or not. And at the same time, in some Slack channels, we're seeing that some companies, they were having very slow times when they were executing this type of task. So we have both elements. So we need another way to determine if this task is worth caching or not. We can take a build scan, of course, but one single observation is not going to make our investigation worth, right? That's why, given the Nelson presentation about the Gradle Enterprise API, we use the Gradle Enterprise API to retrieve more information and not having only a single source of data. So in this case, we have the Gradle Enterprise, the Gradle API, and we were using, by the way, Android X. So we were investigating the Android X project. It has a ton of models, cool use cases. The first thing that we need to do is retrieve the builds. After that, we need to retrieve the different Gradle attributes and filter, because the initial call is going to send you all the build scans, and we want to target some specific scenarios. It's not the same executing a task in CI than locally. Locally, you're going to have more incremental outputs than in CI. So we wanted to check only CI. We want to check one specific project and some specific task. And finally, we are going to analyze with the cache performance endpoint more information about the caching. And finally, we are going to filter, because we need to filter by type. And here are the results of our investigation. So we were checking the Gradle Enterprise Android X public instance. Initially, we were requesting 200 builds, and after the filtering was around 85. And the final result was that for executing the task was much expensive than requesting the task from the cache, of course. And that was the real data that we wanted to apply in our projects. Instead of thinking that, if it's not worth caching this task, or it's worth caching this task, imagine that you disable the caching for this task, for this project. You're adding an extra incremental time. But we have more things to show. So we were showing or aggregating the information based on the type of task. But we can display the information based on a specific task and generate a report with a negative avoidance savings by task. So you have like the last two columns are showing the remote execution, the remote mean time and the task mean time. And for this task, we were seeing this negative avoidance savings. And guess what? Everything was related with the Android test execution. So Dex merging task is worth caching for the normal build variance, but when you're working with Android test, there is something wrong. That's why we are going to start talking with the Android Gradle plugin guys, because we want to see if something goes wrong in this Android test execution. Because it's not the first time that we have seen something like this. I wrote a simple code if you want to check with generating these reports. So it's using, of course, the Gradle Enterprise API, Ktor, Picnic to display the information, and clicked. That's totally a recommended library if you want to generate command line interfaces in Kotlin. It's totally awesome. And with that, I'm going to back to you, Nelson.
Thank you. All right. So the next couple slides, we're going to go into some details on how to use this API. These are the 3 APIs that Inaki pointed to earlier. This is kind of the output that you get from asking, for example, get Gradle attributes. This is what you get from get Gradle build cache performance. You get detailed execution times, fingerprinting summaries, avoidance summaries. So let's say I wanted to write some code to get the user with the slowest average build time on my team. So if I have the list of builds, I kind of skipped over the whole just fetching list of builds. You just create a retrofit service, and go builds and how much time you want. So then you have a list of builds, and then for each build ID, you ask it for to get Gradle attributes that'll give you the usernames. And with that, you group all the builds by username, and you map the username to the user's builds, and get the average build duration of each one. Then you simply sort by descending by the second value in the pair, which is the average build time, and then you can just print out a list. Who is the username and their average build time on your team. And so when you run that, you get an output that looks something like that. So if you wanted to figure out which tasks have the highest negative avoidance savings, it works very similarly. In this case, you use the get Gradle build cache performance API. You filter task execution by tasks where the avoidance savings is less than 0. Group by the task path, or you can group by task type, whichever one you want to analyze. You do the same mapping operation you did in the previous example. And once again, get the average avoidance savings. And then you sort it, and then you get a nice little list just like that. And the output would look something like that. If you wanted to get the user with the most build cache errors, here's a little example. I'm not going to go through it line by line. But I'll also have a link to these examples on my GitHub at the end, so you don't need to copy all this code. So yeah, we also have a thing we call the project summary, which is something we're working on. It's not quite ready yet, but it'll give you which are the slowest projects across my entire organization, which are the slowest tasks in those projects, which projects are the most active, and then of those slowest tasks, you'll also get more detailed information, which ones have the highest avoidance savings, which ones don't, things like that. So yeah. So with an output like this, for example, you'll see that this task has a cache miss rate of 100%. This task has a cache miss rate of 9%, and that'll help you really dive in and understand which tasks need to be taken a look at. So yeah, I also just wanted to point out a couple of new Gradle Enterprise features for Android, in case you're not familiar. We have a slowest test dashboard, so oftentimes if you want to speed up your builds, the easiest way is to make your slowest test faster, because it's often the longest poll in your build time, and you can either break that test up or make it faster somehow. You can also learn which tests are flaky with the flaky test dashboard. And now you can also get Android instrumentation test results in build scans. So yeah, here's an example of what that flaky test dashboard looks like. You can filter by flaky, by execution time, things like that. There's a bit.ly link here. In this case, this is sorting by our team here at Gradle. This is our flaky test dashboard. It's public on ge.gradle.org, so you can take a look at it, find out what the Gradle team's most flaky test is if you're curious. Before I finish the talk, I always need to ask this question. How many people here use Room by Google? All right. So I just need to complain very quickly for a second. Did you know that if you use Room and this as an annotation processor argument, and you have that schemas folder, you're passing an absolute path to the compiler argument, which, as we discussed earlier, this causes cache misses. The other issue here is that all your variants are going to be writing to the same output directory. So that's overlapping outputs, which prevents Gradle from caching something because it's a non-exclusive output directory. What's also interesting here is that the schemas, the old schemas, are stored in the same folder as the new one. So that's the input and the output folder are the same. There's another issue here, which is that cat removes the contents of the output directories, so it's a really tricky situation to make this cacheable. It's really frustrating. I would really please ask you to star this issue because it's existed for a very long time, and I really want to make some noise about it. If you scan that QR code, it'll take you there. Please do that. I gave a whole talk about it last year and nothing's happened, so yeah. Anyways, here's some more resources. So here's like the link to those build validation scripts I talked about. Here's the Gradle Enterprise API manual. Here's our Gradle Enterprise API samples directory. Here's that Kotlin sample I had. And then there's also a link to, Inaki's sample with the Gradle Enterprise API reports. And yeah, there's that room bug, in case I didn't mention it earlier. Please star it. And link to the slides and all that. So yeah, thank you for coming.